Everyone knows them, everyone's seen them, and a lot of people have worn them. But what almost no one imagines is what really happens inside the factories where Nike sneakers are born. Are they all made by robots? Do they really use recycled trash? And here's the big question. How can a sneaker that costs $20 to make end up selling for $200 in the store? What's behind this product that became a global symbol of style, performance, and status? Most people think it's just about stitching a few pieces together, gluing on a sole, and that's it. But the truth is far more complex. The journey that turns discarded plastic into a high-performance sneaker involves chemistry, heat, pressure, and global business decisions. There's sweat, impact testing, cutting-edge technology, and a lot of quality control. And did you know that one of the most important steps still depends on the human touch? Here's another one. Have you ever been fooled by a fake pair without realizing it? If you're like me and often catch yourself wondering, how is that even made? Or, who came up with this crazy idea in the first place? Then you're in the right place. It all starts with an idea, a spark of inspiration from sports, street culture, or urban life. Before a physical sneaker even exists, there's a concept being shaped with surgical precision inside Nike's design labs. Engineers and designers work with advanced 3D software, testing combinations of materials, structures, and colors. These digital models already simulate how the shoe behaves on a real foot. This early stage is quiet but full of creative tension. And that's where the questions begin. Will it handle the impact of a jump? Will it be light enough for a marathon? Once the design is ready in the virtual world, it comes to life in the real one. Each piece is cut with high-precision machines, many equipped with laser systems that work as delicately as a surgeon's scalpel. Every layer, from the fabric that wraps the foot to the sole that touches the ground, is shaped separately and then assembled like an industrial puzzle. During this stage, the sound of machines fills the factory like a metallic orchestra. A curious detail: some materials are stitched without thread, using thermal fusion, which removes visible seams and boosts performance. The final assembly is almost like a robotic ballet. Machines apply adhesive with millimeter precision while skilled workers supervise fittings, seams, and finishes. Then, the sneakers go through heat chambers that seal the structure together. It's a process that combines strength, science, and patience, and everything has to be flawless. But the most fascinating part is yet to come, because what makes a sneaker truly revolutionary often starts with what no one can see. Behind every pair of sneakers lies a journey that begins long before the factory. One of the main materials used in Nike sneakers is recycled polyester, often made from plastic bottles collected in cities, beaches, and landfills around the world. They're washed, shredded, and turned into strong, lightweight, flexible fibers. It's amazing to think that what once was waste now finds new life on the feet of athletes, students, and everyday workers. Another standout material is fly leather, a modern alternative to traditional leather. It's made by combining recycled natural leather fibers with high-performance synthetics. The result is a fabric that's lighter, stronger, and far more sustainable. This innovation was born from a growing demand inside Nike's own labs to create something beautiful, durable, and eco-friendly at the same time. It's not just technology, it's a conscious choice. And the most impressive part? Most people have no idea any of this happens when they slip on a new pair of sneakers. Even the soles use compounds made from recycled rubber, leftovers from other productions that are given new life through molding. In some factories, you can see piles of colorful scraps being ground, pressed, and shaped into pieces that look like tiny building blocks. This practice not only cuts waste but also makes production cheaper and more efficient. And if you think that affects performance, think again. These recycled materials go through the same rigorous testing as conventional ones. But in the end, how does Nike manage to turn all this into some of the most desired products on the planet? Most of the Nike sneakers you see in stores around the world aren't made in the United States. They're produced mainly in Asia. Thailand, Vietnam, Indonesia, and China together account for more than 80% of Nike's global production. These factories are massive, some with over 10,000 workers, operating in shifts that run 24 hours a day. The environment is humid, noisy, and heavily monitored for quality. Every pair of sneakers goes through traction, durability, and even simulated running tests on different types of surfaces. A common question people ask is, how can you tell if a pair of Nikes is genuine or fake? One of the first clues is the stitching and the smell. Authentic pairs have clean, even stitches with no loose threads, and don't have that strong glue odor often found in counterfeits. Another key detail is the midsole. Genuine Nikes use high-density foam that bounces back to its shape within seconds after impact, while fake versions sink and take longer to recover. Inside the shoe, you'll also find a serial code printed on the label. You can verify it directly on Nike's official website. The countries where Nike sells the most are the United States, China, Brazil, Mexico, and several in Europe. Interestingly, many of the shoes sold in these regions are actually made in nearby Asian factories. So don't be surprised if your authentic sneakers say, "Made in Vietnam." That doesn't mean they're lower quality. These factories follow the same standards as Nike's main headquarters. What changes are the logistics and access to certain technologies. But to really understand how Nike's production became a global network, we need to go back to the beginning of it all. Nike didn't start as a giant. Back in the 1960s, the very first batch of sneakers was made almost entirely by hand, in a small garage in Oregon, USA. Bill Bowerman, one of the founders, was a track coach who famously used a waffle iron to mold rubber soles. Yes, a waffle maker. He poured the rubber mixture into the mold, waited for it to harden, and then glued it to the base of the shoes by hand. That homemade experiment became the seed of the traction technology that would later revolutionize athletic footwear. As time went on, production grew, and what started as improvisation became standard practice. Nike's first outsourced factories were set up in Japan, and later expanded to Taiwan and South Korea. At that time, machinery was simple: pneumatic cutters, manual presses, and short conveyor belts. Automation didn't exist. Most of the work was done by hand, with workers using basic tools on benches. Each pair of shoes took hours to complete, but despite that, success came fast. Athletes started wearing Nikes in the Olympics, and the name quickly became synonymous with innovation. By the 1980s, Nike had begun using more powerful equipment imported from Europe and the United States. Presses became stronger, cutters used industrial steel blades, and sole molds started being produced at scale. That decade also saw the first internal tests for impact and flexibility. Production increased dramatically, but quality control was still done manually. It was around this time that Nike decided to shift part of its operations to Asian countries, looking for scalability, workforce availability, and more affordable infrastructure. When the sneakers are finished, they don't go straight to stores. First, they pass through a final inspection area where every pair is cleaned, labeled, and carefully packed into boxes. The packaging is made of recycled cardboard and includes details like model, size, and country of origin. Some newer models even include a printed QR code that links customers to an official product page. This not only helps fight counterfeits but also gives consumers a richer, more interactive experience. Once boxed, the sneakers are stacked on large pallets and sent to distribution centers located near ports and airports. These centers act as intermediate hubs where pairs are sorted by model, size, and destination region. From there, international logistics takes over. Trucks, cargo ships, and airplanes transport Nike sneakers to more than 190 countries. In some cases, the time between manufacturing and store shelves can be less than 20 days, depending on local demand and urgency. At their final destination, products are delivered to physical stores, online marketplaces, and authorized resellers. Nike also maintains its own storage hubs in major cities to speed up express deliveries. During major events like product launches or limited edition releases, distribution happens under tight security and complete confidentiality. All of this ensures that every pair arrives intact, on time, and with the quality customers expect. But behind all this modern efficiency, there are still human stories, questions, and reflections that can't be ignored. After seeing everything that goes into making a pair of sneakers, it's hard not to be amazed. The engineering, the materials, the global scale, everything feels so efficient, so perfect, so automated. Yet one question remains. In the future, will there still be room for the human touch, or will we depend entirely on machines to create the things we use every day? Many Nike fans don't realize that behind the sleek, modern look, there are still people checking quality with their own hands. Workers who know every texture, every stitch, and every tiny flaw before the machines even detect it. But how long will that last? At what point do we trade emotional precision for digital efficiency? If you made it this far, leave a greeting in the comments and tell us which city and country you're watching from. And of course, if this video taught you something new or sparked a curiosity you didn't know you had, give it a like and subscribe to the channel.